So one of the things that I'll just mention briefly, or maybe not so briefly, about the paper that was written that compiled all of this data from the red-gray chips. The first thing that we wanted to do was to establish that all of the chips were similar, and that and when I say all of the chips collected from the different dust samples that were collected from different areas in Manhattan, from different individuals who were not associated. So once we collected different chips from the different samples, we then took photomicrographs as well as looking at them in the scanning electron microscope, and then compositional analysis of both the red layer and the gray layer. And all of these things showed that these red-gray chips are the same. The compositional analysis of the red layer was the same. The compositional analysis of the gray layer was the same. Their appearance and cleavage habit or microstructure appeared the same. All of those things appeared the same. Then we ran multiple samples through the DSC, the differential scanning calorimeter, and found that they behaved almost identical. The peak heights were very similar. The location of the peaks were exact. And so once we were able to establish that these things were all the same, that's when we were able to then, with more confidence, try and determine what these things really were. And so now what we have is from the composition of the red layer, we have an aluminum peak, we have a silicon peak, we have the iron and the oxygen, as well as other peaks. And one of the things that we did to ensure that we weren't getting surface contamination was we just took some of these chips, which are very, very small, by the way, and under a microscope we were able to cleave these chips or break them in half and then study the fresh or the broken surface so that we weren't getting surface contamination. These things were coming in bags of dust, so who knows what kind of contamination you get on the surface. So we were looking at these broken or these clean edges in order to get the composition. And that's where we found the silicon as well as the aluminum peaks and the iron and oxygen peaks in abundance and throughout all of the red layers in all of these chips. The gray layer was also interesting. We found that was mostly iron and oxygen. And again, each gray layer was identical in its compositional analysis as well as its appearance. And then what we found from the DSC, there was actually some significant findings in the residue. After igniting these chips in the DSC, we found microspheres that were very shiny in appearance. Some of them were almost glassy, a little translucent. And we found that the composition of these microspheres, of these very small spheres, many of these spheres had the exact or identical composition or very similar composition as the spheres that Steve was finding in the dust samples. They were also very similar to spheres found in thermite, in commercial thermite. Once you ignite commercial thermite, you also get microspheres. And the composition was very, very similar. And that led to the conclusion of the paper, which was, we've got some form of thermite in these red-gray chips. And I think it's a very, very strong conclusion. There have been some that have argued that these red-gray chips could be paint of some form. We actually did a study on some epoxy paint. We put that in the DSC. We found that paint would just burn up and turn to ash. So you may get a minor exothermic peak, but it's not energetic. It's a very smooth, wide peak, and it's certainly not an energetic material. As part of the residue of the paint that we ignited in the DSC, the actual paint, it was basically ash. There were no microspheres found in the paint sample that had been ignited in the DSC. We also took paint that came off of the WTC steel and looked at that in the SEM and did a compositional analysis of that and found that it was not similar to the red-gray chip or the red layer of the red-gray chips. So it wasn't, the red-gray chips are not the primer paint that was used on the WTC steel. There are a lot of questions that came up during the paper that have been left unanswered or that are unanswered and need to be answered. Just an example, what is the gray layer? What was the purpose of the gray layer? We know it has a lot of iron, we know it has a lot of oxygen, and we've found that we do see some, there's a hematite phase, but there are other phases present in that gray layer, and we don't know quite what that gray layer is or how it's adhered to the red layer. Certainly further study needs to be done. We certainly need to be doing more work to find out what that is. Occasionally we would find an intermediate layer between the red layer and the gray layer, which was rich in carbon, perhaps a polymer type layer. But again, we need to go further with that study to figure out what those things are. There are some characteristics of the red layer that are rather significant. One is that it's not homogeneous. There are different particles or grains within the red layer that we studied. One appeared very bright under backscattered electron microscopy, which indicates a heavier phase. And we looked into those small particles. They were rhombohedral in shape and very consistent throughout the layer. They were about 100 nanometers in size, roughly. And very consistent in both their size, the shape of them, and as well as the composition that we could get from the SEM. Additional studies in the TEM found that these were iron oxide phases. So these particles, these small bright particles, they appear bright in the SEM images in the paper. These were in fact iron oxide phases that we were able to pin down using the transmission electron microscope. There were other phases present as well, or other particles present in the red layer. There were some plate-like phases or plate-like particles, and those again, those were consistent throughout the red layer, throughout all of the samples that we found, and those appeared to have a higher aluminum and silicon peaks in their compositional analysis. And one of the significant things about what we find in the red layer is the fact that these particles that we find in the red layer are the fact that they're consistent, and the fact that, I mean, consistent in shape and in composition and in size leads me to believe that these things are not naturally occurring materials. The red layer is not a naturally occurring material. Sure, you have iron oxide everywhere. That you have iron, you get an iron oxide. But you don't get them in nice little 100 nanometer rhombohedral shaped particles inside of inside of a red layer, a very small red layer. And by the way, these, just to give you a reference on the size, these particles that are in the red layer are thousands of times smaller than, say, the width of a human hair. So these are very sophisticated particles, very sophisticated materials, not materials that we would expect to find in the demolition debris of a building. In order to get that kind of consistency with shape and size and to be that small, these really are sophisticated materials, and probably only developed in a laboratory. They may be processed outside of a laboratory, but they're developed in a laboratory. There were several other things that were found that we put into the paper that I think are very significant, and the conclusion of the paper really does fit well with the data that we collected. Our conclusions were that the red-gray chips are some form of thermite or a nanothermite or an energetic material which is very similar to thermite. And those conclusions are it's a very strong conclusion given the data. Now others may say, well, could it be something else? Certainly. It certainly could be something else. I'm not about to say that we've completely ruled out everything. But the conclusions we made in the paper are very strong given the data. If there's another possibility, that's something that somebody can come forward with using the same very stringent scientific method that we used in this paper, and publish that, and they'll find, I can guarantee they will find that our work is completely reproducible. If you find other red-gray chips, they will look and have the same composition and the same behavior in the calorimeter as the red-gray chips that we found. Now, if they come up with different conclusions than we do, that's their prerogative, of course, and I'd like to see that. I'd like to see other people looking at these things, because that reproduces our results, and it also brings us to a discussion which needs to happen. We need to be talking about this. There needs to be another investigation of the events of that day. And that's why I signed the petition at A&E, at the A&E website, A&E for 9/11 Truth, Architects and Engineers for 9/11 Truth. That's why I signed the petition, and I do believe there needs to be another investigation.